All right, so simplifying polynomials. We have talked about adding and subtracting polynomials, and we talked about multiplying polynomials. Those were all fairly simple, but as we fear in mathematics, things always get more complicated, especially when it comes to dividing. So dividing polynomials is the hardest of the four operations when it comes to polynomials. Today we are going to talk about dividing a polynomial by a monomial. That one is fairly simple. We will also talk about using long division for dividing two polynomials. That one tends to be a little more complicated. But let's start with the easier of the two. So dividing a polynomial by a monomial. A monomial, of course, means that we are dividing by a single term. So if I take my division problem and I rewrite it as a fraction, I will only have one term in the bottom of my fraction. So let's say that I start with the problem 6x to the fourth y cubed plus 12 x cubed y squared minus 18x squared y, and I am dividing this by 3xy. I am going to start by rewriting this as a fraction. So I will have 6x to the fourth y cubed plus 12x cubed y squared minus 18x squared y all over 3xy. The reason that I'm going to do this is because if you have a fraction that only has one term in the denominator, that means that you are allowed to split the fraction up so that each term in the top is going to be over this denominator in the bottom. So I'm going to have 6x to the fourth y cubed over 3xy plus 12x cubed y squared over 3xy minus 18x squared y over 3xy. When I do this, each of these fractions looks very similar to a type of problem that we did last section. And so what we're going to do is we are going to simplify each of these monomials, each of these single terms, using our properties of powers. So for the first term, 6 over 3 simplifies to 2. X to the fourth over x, division of the same base means I subtract exponents. Since I cannot see an exponent on the 1, that must have a 1. So 4 minus 1 gives me x to the third. Again, don't see an exponent, must be a 1, so 3 minus 1 is 2, so y squared. That's the first term. Plus, second term, 12 divided by 3 is 4. X cubed over x, subtract the exponents, gives me x squared. And then y squared over y, subtract the exponent, gives me y to the first. And I do not need to write the first power since it would be assumed to be a 1 if I don't write anything there. Minus 18 divided by 3 is 6. X squared over x is just going to give me x. And of course, y divided by y, anything divided by itself is 1. Those are just going to cancel each other out, since if I multiply 6x by 1, it would just be 6x. So I'm not even going to put anything with the y's down here. If I subtract the exponents, it was y to the 0, which remember is 1. So the y's are now gone from that third term. And if I look at these, I notice that none of these are like terms, so that is my final answer. So this is dividing by a monomial. if I'd had something written this way, 18x squared y plus 27x cubed y squared z times 3xy, all being raised to the negative first. Notice that while this looks like a multiplication problem, it's actually a division problem in disguise. And that's because of this negative 1 exponent over here. The negative 1 exponent, remember, means that the base, notice the base in this case is the entire parentheses here, the base would have to go across the fraction bar in order to receive a positive exponent. So this whole parentheses would have to move down to the bottom of the fraction in order to receive a positive 1 power. So now I would have a large fraction, and because the whole parentheses would have a positive 1 power, that would no longer be doing anything for those parentheses, so I'm just going to go ahead and drop those parentheses. Well, now I can see that this is a division problem. It is written as one giant fraction, and I could go ahead and perform that division. So why don't you go ahead and do that right now. If you perform the division for this problem, you should find that the answer is 6x plus 9x squared yz. Next, let's talk about long division. Long division is going to be a much trickier one. And here's how it's going to work. I'm going to be dividing a polynomial by another polynomial. And just as a reminder of long division, let's go ahead and take a quick look at dividing regular numbers using long division, because the process is going to be very similar when we deal with polynomials. So let's say that I had 1,247 divided by 8. Now with long division, remember, I would first take this 8 and ask how many times does 8 go into 1? Well, it doesn't, so I'm going to extend my question to the 2 as well. So now I'm asking how many times does 8 go into 12? And the answer is once. So I put a 1 over the 2. 1 times 8, I'm taking this number up top, times this number out front, so 1 times 8 is 8. I put that below the 12 that I was talking about, and I subtract these two. 12 minus 8 is 4. Next, I bring down the next digit, and I ask the same question. How many times does 8 go into 44? And the answer is 5, so I put a 5 up above this 4. I take 5 times 8, so this number up top times this number out front. The answer is 40, so I'm going to put 40 down below here, and I'm going to subtract this from the 44. That's going to give me 4. I bring down the next digit. I ask how many times does 8 go into 47? This time the answer is 6. No? 5. Still 5. So 5 times 8 is 40. Subtracting 40 again, I get 7. I no longer have anything left over here. Now, we had learned back in grade school or wherever, when we first started learning about decimals with long division, I could put a decimal and some zeros, but I'm going to stick with remainders. So I'm going to put an R here for remainder. My remainder is 7. Now what would this mean? This would mean that I would have an answer of 155 and 7 over 8. So this means that 1,247 divided by 8 is equal to 155 and 7/8. Okay, I'm going to use a very similar process, same type of process, to divide polynomials. So I'm going to take x squared plus 3x minus 40, and I'm going to divide it by x minus 5. I'm going to set this up as long division. So x squared plus 3x minus 40 being divided by x minus 5. Now I'm going to be asking the same question, but I'm only going to focus on this x out front here. I'm going to be asking the question, how many times can x go into the first term? That's what I'm going to focus on. The 5 is just going to kind of go along for the ride when I answer these questions. So I ask the question, how many times does x go into x squared? The answer is x. If I take x squared divided by x, I get x. Now what I'm going to do is I'm going to take x times this entire front part. So I take x times x minus 5. X times x is x squared. Line that up with the x squared underneath here. X times negative 5 is the minus 5x. And now, similar to what I did in the long division up here, I'm going to subtract this polynomial underneath. Notice this means I have to distribute the negative sign. So this becomes minus x squared, and then this would turn into a plus 5x. So that's really 3x minus negative 5x plus 5x gives me 8x. So now I ask the question, how many times does x go into 8x? The answer is positive 8 times. So I put plus 8 up in the top here. I take positive 8 times this entire x minus 5 out front. Positive 8 times x is 8x. Positive 8 times minus 5 is minus 40. Notice I will also be bringing down this minus 40 here, just like I did in the long division with the numbers. And now I'm going to subtract. 8x minus 40 minus 8x minus 40. Well, 8x minus 8x is 0. Negative 40 minus negative 40 is 0. Notice I no longer have any other terms to bring down, so this is my remainder, but since my remainder is 0, that means I have no remainder. This up here is my answer, x plus 8. So x squared plus 3x minus 40 divided by x minus 5 is x plus 8. Let's take a look at one more example. All right, so let's say that I would like to take g to the fourth minus 3g squared minus 18 divided by g minus 2. Now this is something that's very important that we notice in the original problem. We do not have all of our terms in this polynomial. And that is going to be very important. We are going to want to make sure that we see every term. Now what do I mean by missing terms here? Well, I notice that I have g to the fourth is my largest power, but I do not see a g to the third. So what coefficient must the g to the third have had? It must have had a 0 as its coefficient. So when I go to write out this problem, I'm going to write out g to the fourth plus 0g to the third minus 3g squared plus 0x minus 18 is being divided by g minus 2. I want to make sure that I see every term, every power on my variable. Whoopsie, not x, g. I want to make sure that I see every power before I move forward. So now I ask the question, how many times does g go into g to the fourth? The answer is g to the third. So take g to the third times g minus 2. G to the third times g is g to the fourth. G to the third times the negative 2 is minus 2g to the third. And now I'm going to subtract this entire quantity. Please make sure that you either put parentheses around this or immediately distribute the minus sign. G to the fourth obviously will cancel out. That was the whole point. But then I have 0 minus negative, so that means plus. So plus 2g cubed would be positive 2g cubed. Bring down the minus 3g squared. I'm now asking the question g into 2g cubed. And that will be plus 2g squared. If I take 2g cubed divided by g, I get positive 2g squared. So I take 2g squared times g minus 2. I should get 2g cubed, that's the whole point. And then minus 4g squared, 2g squared times minus 2. Subtract, I'm going to immediately distribute my negative, turn that into plus. So I've got negative 3g squared plus 4g squared gives me positive g squared. Notice these will cancel out. Bring down my plus 0g. G into g squared is plus g. So multiply by g, I've got g squared minus 2g. I'm going to be subtracting, so immediately distribute my negative to turn that into a plus. That becomes positive 2g. Bring down my minus 18. G into 2g, well, that's going to be positive 2. Multiply g minus 2 times positive 2. I will have 2g minus 4. Subtract, distribute the minus in order to turn that into a plus 4. I have negative 18 plus 4 gives me negative 14. I have nothing else to bring down, and notice g does not go into negative 14. This means that this negative 14 is my remainder. So I'm going to put minus 14 over g minus 2. That's what we're going to do with the remainder, is we turn it into a fraction at the end. We put the remainder over what we were dividing by.